Welcome back. So we're going to be looking at angle side angle triangle congruence postulates. So two angles and the included side of one triangle are congruent to two angles and the included side of a second triangle, then the triangles are congruent. So here our side is in the included one, right? It's included between the angles, right? So if it's angle A and angle C, it's got to be side AC. If it's angle F and side D, angle F and angle D, it's got to be side FD, right? Because it's got to be between those two angles, right? So it means it uses the vertices as its endpoints. All right, so two angles and the length of a side between them are fixed. The intersection of the other two sides will be fixed too, and the triangles have to be congruent. Right? It's like you're just sending them on a pathway following the angle. They're going to have to intersect at B and E. And we're waiting for the page to turn. There it goes. All right, so here we have a triangle, right? And so the congruent parts are the angles. So angle A is congruent to angle D, and angle B is congruent to angle I, and then the side in between those two. So AB is congruent to DI. Right? So now once they fix that, right, all I can do is just wee, right? And wee. All I can do is follow the lines, and I have to intersect, right? I don't have any other choices, right? So if you fix two sides or two angles and a side, right, you're going to be able to make one kind of triangle. Right, so if two angles and the length of the side between them are fixed, the intersection of the other two sides will be fixed too, and the triangles have to be congruent. Right, you're just following along a path until they intersect. You have no other choices. So I'm going to be solving a whole bunch of problems with angle side angle and reviewing all of the ones we've learned before, which are side 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 and side angle side. But before we do that, a little vocabulary. Right? So I left the words up here because they all look so pretty, and they're in the perfect location, and there's no blippies on them. All right, so reviewing a couple words here: bisect and angle bisector. All right, so bisect is to cut into two equal parts. All right, so in our diagram over here, and this one's not in your notes, but you can certainly add it if you'd like. CD, line CD, bisects segment AB, and therefore AB is divided into two congruent parts. Right, so the statement would be AM is congruent to BM. The reason segment bisector divides a segment into two congruent parts. I think it would be probably a really good idea for you to put this diagram and the words there in your notes if you are one that has a little bit of trouble remembering some of your reasonings and statements on a proof. All right, so here we have the statements and the reason behind it. And then angle bisector. So an angle bisector is a ray that cuts an angle in half, resulting in two new angles that will have the same measure. So here's our diagram. All right, so QP, ray QP bisects angle RQS. We get two new angles that will have the same measure, right? Because it's cutting the one angle in half. So the measure of angle RQP is going to be equal to the measure of angle PQS. So ray QP is an angle bisector. All right, so here a little help with statements and reasons. So the statement, the S there, is angle RQP is congruent to angle SQP. That would be our statement. The reason that we can say that, an angle bisector divides an angle into two congruent angles. All right, so a good little review here on bisector because it's going to come up in this lesson. And so if this is a little bit tricky for you, right, just pause the tape and write those down, and then you'll have them in your notes to refer to, right, and you won't miss these problems. Angle bisector will come up quite a bit in these problems, or enough times to warrant me going over angle bisector. All right, so example here, we want to show that triangle EFM is congruent to triangle GHM. All right, so notice, so when you have a problem like this, the first thing you should do, even if there's measurements in there, is you should mark congruent parts. So 8 has to be congruent to 8. A 90-degree angle has to be congruent to a 90-degree angle. And don't forget these two, right? 2 angles formed by 2 intersecting lines. Actually, 4 angles are formed, but those 2 are opposite one another, share a vertex, and they're formed by 2 intersecting lines. Those are vertical angles. Right? So now let's prove triangle EFM is congruent to triangle GHM. Right? So we know angle F is congruent to angle H, right? Because that was a given. We were given that they're both 90 degrees. Right? FM is congruent to HM. Also a given. We were given that they were both 8. And then we had to figure out that angle FME is congruent to angle HMG because those are vertical angles, and we know vertical angles are always congruent. So now if we look, we have 2 angles, the side in between, all right, so that we know that triangle EFM is congruent to triangle GHM using angle, side, angle, triangle congruence postulate. All right, there we go. So we've proven it using angle, side, angle. Let's look at a few more examples. Actually, I have quite a few more examples in this section here, because this is a good time to review the other 2. And here comes our next problem. All right, so when you're given problems like this where you're trying to prove triangle congruence, right, so the first thing you want to do is ask yourself what data is given to you. Look carefully. Do you have measurements? Right? If you've got the measurements and they're the same in both triangles, you know they're congruent, mark those congruent. Second, if it's not already marked, check and mark the diagram with that information, as well as mark vertical angles and shared sides and angles. Right? So vertical angles are always congruent, shared side and angles are always congruent using the reflexive property. Sometimes the information is not on the diagram, right? It's written next to it. If it's written next to it and not marked on the diagram, mark it, right? Make sure you mark the diagram so you can see it. It's not enough just to have it written. And third, check your congruence postulates. What piece of information are you missing? Side and angle. Where does it need to be for your chosen congruence? Right? You're going back to your congruence postulates. All right, so here a little review. What is the included side for angle X and angle W? Because you got to know included, right, side to be able to use angle, side, angle. Right, so here's angle X. Here's angle W. Right, so vertex at X, vertex at W. Included side has got to be XW. Right? You're going to see the 2 angles names in the name of the side, right? If it's the included side. Right? The other 2 are not included sides. Let's try another one. And just waiting. There we go. What's the included side for angle X and angle Y? All right, so let's mark angle X. All right? There's the vertex on angle X. Let's mark angle Y. It's got to go between those 2 points. So your side is literally given by your angle. Angle or side XY or YX, either one is the same. Right? So segment YX is our answer here. Right? So hopefully you can recognize included sides. All right, so let's look at the next problem, some more triangle congruence. Some of these we'll solve as a proof, and some of these are going to be a question like this, a multiple choice question. All right, so what piece of information do we need to have angle, side, angle congruence between the 2 triangles? The first thing you want to do is mark your given information. So here we have information that we're given. It's not on the diagram. That's your first step. Put it on the diagram, right? So when you mark the figure. By the way, some of these problems that we're solving will be in your notes. Right? So just be looking at your notes and seeing if it's there. All right, so to mark the figure, right, we're going to mark what we're given. We're given angle ONP. So ONP, right, it's right there, right, N. Starts at O, goes to N, and then goes to P. That'd be right there. It's congruent to MNP. Starts at M, goes to N, then to P. So that's this angle right there. And OPN, right, starts at O, goes to P, and then N. That's this angle here. And notice I put a different number of congruence marks, right, because I don't know that the angles with one congruence mark and two are the same. I just know that angle OPN is congruent to angle MPN. All right, so that's going to be right here. Right? Go start at M, go to P, and then N. That's right there. All right, so that's our given information. And then, is there anything else we know? So interestingly, the piece of information we need is actually something we should know. Right? Notice that both triangles share this side right here. Right? So we know that happens to be congruent using the reflexive property. And that actually is enough for angle side angle. Right? So the thing that we need, NP congruent to PN, is literally the thing we know. By the way, there is also one mistake there. It really should say NP congruent to NP. Because notice that the N is the two angles with the N as the vertex are congruent. The two angles with the P as the vertex are congruent. Notice this isn't a reflection of one another. It's not that angle N is congruent to angle P, but N is congruent to N. So it actually should go the same way. NP congruent to NP. I don't know what it says here. There we go. So NP congruent to PN really should be NP congruent to NP, but we won't tell them. It is true by the reflexive property. If you're marking the diagram to show the corresponding congruent parts, you can see that NP congruent to NP is needed, right? And it's needed, and we know it, right? So that's good. All right, let's try another one. And we're waiting, and will it come up? There it is. What piece of information do we need to have angle side angle congruence between the two triangles? All right, so here we have nothing but what's marked and what has to be true. All right, so here are two angles, angle ADB and angle CDB, right, are linear pair angles. Notice they form a straight angle. They form a straight line. They are linear pair angles, right? So together they equal 180 degrees. Well, if angle D here, angle CDB, is 90 degrees, then this one has to be 90 degrees as well, right? So now we have two pairs of congruent angles. If we want to use angle side angle, we need to know that the side between them is congruent, right? So we need to know that DB is congruent to, it really should be DB. Someone there was really liking to reverse them. Right? But we can see that angle B is congruent to angle B and angle D is congruent to angle D. It should be DB. Right? They're not flipped from one another. But we'll forgive my multiple choice question writer. So DB is congruent to DB is true by the reflexive property. Since angle DBC is a right angle, angle BDA must also be a right angle since they form a linear pair. The included segment we need is angle DB congruent to angle DB. All right, so here's a very good explanation of what we need to know to be able to prove the triangle is congruent using angle side angle. Right? So you can use that as a model example. Let's look at another problem. And let's see, we have another Angle side angle problem. Why? Yes, we do. All right, so now we want to know whether y angle FME is congruent to angle GMH, right? So let's take a look. So angle FME, that's this angle here. Angle GMH is this angle here. Well, what kind of angles are those? So if you said angle side angle, you were wrong. That proves triangles congruent, not angles. All right. Just because you're included angle doesn't make you congruent. And why isn't D redundant? Why are they congruent? No, they're congruent. That's like saying because, just because they're vertical angles. Right? So I don't know if there's an answer underneath there. So there you go. So vertical angles. Right? So mark congruent vertical angles when you see that two lines intersect. All right, so we should know that those angles are congruent using vertical angles. Now, if we were asked this, y is triangle FME congruent to triangle GMH, that would be angle side angle triangle congruence postulate. Right? Because now we have two angles on the side between them congruent in both triangles. And here comes our next problem. Now, all right, what type of congruence exists between the two triangles? So now we're going to include all of the ones we know. Side, 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 side angle, side, angle, side angle, or not congruent. And we're going to choose not congruent anytime we can't prove it's congruent. Always your first step, mark your given information. So we're given that TU is congruent to ST. We're given that UQ is congruent to TR. And we're given that QT is congruent to RS. Right? So I hope you know which one. So think in your head which one. Or shout it out your computer. Right? Which of our congruence postulate applies? Why, it is side, side, side. We have three sides in one triangle congruent to the corresponding sides in the other triangle. Right? Those triangles are congruent using side, side, side triangle congruence postulate. All right, let's do another one. See if you can get that one right. And so I think all the rest of these are pretty much all problems for us to solve. And every so often we have a little review question in just to remind you, because it might come up in another problem later on. All right, so we want to know the relationship between the angles shown. Notice that you have parallel lines and they are cut by a transversal. Okay, so we worked with parallel lines cut by a transversal, and we know if we have parallel lines cut by a transversal, that angle 1 would have to be congruent to angle 2, and that angle 3 would have to be congruent to angle 4. Do you remember why? What kind of angles are those formed by parallel lines? Right? Well, those are alternate interior angles. We know alternate interior angles formed by parallel lines are congruent. Okay. So in the next problems, we might have triangles created by some parallel lines. Right? And if we do, we'll remember that the alternate interior angles are congruent. Right? So this one's just a little review, right, about our angles here, and a reminder of that any alternate interior angles formed by parallel lines are going to be congruent. We're not going to, by the way, run into alternate exterior angles, right, because they'll be outside of our figure there, outside of the triangles. Right? So we won't really be working too much with alternate exterior angles, but we will with alternate interior angles, and we might with corresponding angles as well. Right, so those are the two that might come up with our triangle congruence. And next page, okay? So when you have overlapping figures that share sides and/or angles, marking the diagram with the given information makes it much easier to understand the problem. Often it's also helpful to redraw the triangle separately so you don't get confused. When you have overlapping triangles, those triangles will create little triangles. So let's see what that looks like in this problem here. All right, so we want to figure out what type of congruence exists between the two triangles. So do you see the overlapping triangles? The big triangles are creating two little triangles. And so we have to figure out what triangles do they mean, the large overlapping ones or the little triangles. All right, so we've got KL, we've got LJ. So LJ is a side in the big triangles. They don't mean those little triangles, they mean the big ones. All right, so it may be helpful to just draw them separately. It doesn't have to be perfect. All right, so here we have one triangle, right, that's formed by K, L, and N. You see triangle KLN there? This one right here. Right? And then we have another triangle, and the two triangles overlap, and that other triangle is, I'll try to make it face the same way. Doesn't have to, but I'll try. This one would be triangle JLM. Right? So it makes it a lot easier if you draw these out separately, right? The blue triangle and the green triangle. Now we can mark the triangles using the information that we're given. So we're given that KL is congruent to ML. We're given that LJ, there's LJ. LJ is congruent to LN. And we might look at that and say, oh, that's it. I only got two sides. What can I do? Right? So if you don't see anything else, go back to the picture. Is there something else that has to be congruent? I see an, so let's take a look at our angles. So the green triangle there has triangle J, or has angle J, angle M, and angle N. Angle L. Right, so angle J, angle M, and angle L. The blue triangle has angle K, angle N, and angle L. They both have an angle L. But are they the same angle L? Right, because sometimes maybe we're not going to be the same. Right, so let's take a look. Where's our angle L? Oh, that's right here. So look at that. So that angle is shared by both triangles. Right? So angle L, and I think this one's in your notes, is shared by triangle KLN and triangle, I'll list it, it doesn't really matter how I list it right now, but I'll try to make them match up a little bit. So actually, you know what, I'll just list them any old way, JML. We'll match them up if we figure out whether or not they're congruent. All right, so notice they both have an L. They both have angle L, right? And that is the same angle for both triangles. So now I see a side, I see two sides, and notice if I follow the sides, they meet right here at angle L. That's the included angle. So if we have two sides in the included angle, that must be side angle side. Right? So remember to draw your triangles separately. If they overlap, mark the information you're given, and then if you're not sure, go back to the original. Look for any shared parts, right? Because those are going to be congruent to itself. Right? So now we know the triangles are congruent. Let's match them up properly. So triangle KLN is congruent to triangle. So K is going to go with, K goes with M. Right? So it'd be triangle M, and then L, and then J. There we go. Right? And so now we proved our triangle's congruent. And let's hit the little box. Sometimes you don't say anything though. How about this one? Yep. It says side angle side. We got it right. Right, so mark your congruent parts. I'm getting very close to where I may want to split this video into this section, angle side angle, into two videos. Let's look at our next problem, and that's going to help me decide if I want to start that problem on the next video. This is a little bit longer problem. So I want to start this one on the next video. So we're going to stop for now, and we'll come back with this problem. Thanks for watching, and bye for now.